Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at circles and triangles. On the screen, we can see we have a triangle. I have 3 points on a set of axes and I've connected those 3 points together, okay? I don't know anything about the triangle. It doesn't look like it's a right-angled triangle. Might be isosceles. These two might be the same length. It could be equilateral. All sides could be the same length. I don't know. I'm not going to assume anything. I'm just going to not assume, actually know for certain that it's a triangle, okay? Now, what if I did a circle that, and I'll do it freehand first, that went through this point like that, through that point like that? Would it make a perfect circle? Well, let's go back and let's draw on a perfect circle, because if we connect those 3 points together with a circle, we get this. There. We can see that it's a perfect circle, okay? So we can always take 3 points on the circumference of a circle, connect those points together to make a triangle, and then this circle out here that passes through all of these points is a perfect circle, and it actually has a name. It's called a circumcircle, okay? And the reason for that is because all these 3 points are on the circumference, so we call it the circle that passes through all these 3 points. We call it the circumcircle, okay? And the centre of that circle is the circumcenter, okay? So because it's the centre of this circle, maybe about there, it's called the circumcenter, okay? So we know that that shape in the middle is a triangle, but it's got 3 sides, and those 3 sides are made up by connecting 2 points on the circumference of the circle together, okay? We'll highlight. There's 1. Let's make it a straight line. There's 1, okay? There's another connecting those 2 points together, and in green there is another connecting those 2 points together. Okay, so we can see that what we've actually got there is 3 chords. In the last video we introduced what a chord is. A chord is a line that connects 2 points on the circumference of the circle together. And that's exactly what we've got going on here, okay? So here's 3 chords. What if we took each chord and we drew in its perpendicular bisector? Let's do that. And quite easily, I have done it already here. We'll drag this on. It looks like it should be about, I'm not going to get this perfect, maybe about there. Does that look about right? Maybe not, actually. Maybe about there, would we say that's a bit better? Yeah, maybe there, okay? Let's say those were the perpendicular bisectors. So what we have now is that line is equal to that line in length. This line is equal to that line in length. And this line, we'll do 3, is equal to that line in length, okay? Our perpendicular bisectors, quite interestingly, meet at the circumcenter, or the centre of the circumcircle, okay? The circumcenter, which is there. That is the centre of the circle. So if we have a triangle and we connect the points together to form that triangle, and then we draw a circle that passes through all of those 3 points, if we then put the perpendicular bisectors on of each side of the circle, or the 3 chords, they cross at the centre of the circle. Okay, so let's just first of all look at a certain type of circle in, certain type of triangle, sorry, in a circle. I have here, it is a chord, but it's actually the diameter of the circle. It's a chord because it connects 2 points on the circumference together, but it passes through the centre of the circle. So as you know, we call that the diameter of the circle. I have 3 points on the circumference. I have this point that we've called R, this point here, and then that point there. We've called that R for a reason, but we'll get onto that in a minute, okay? What happens if I connect P with this point here, and I connect Q with this point here. Well, let's see what that would look like by drawing in these yellow lines. That's what we've got there, okay? And we have just formed a triangle in a circle. And look at the title. It's going to be a right-angled triangle, but how can that be? Well, because we've got the diameter, and then we've connected this point here, and we've connected that point there. This is our right angle. The right angle is there, okay? So if we have a diameter and we have a chord coming off from one end of the diameter and another chord coming off the other end of the diameter, they meet at a right angle, okay? Let's look at that somewhere else on the circle. Let's look at that with this point here, and I think that is the green lines. Yes, it is, okay? Let's connect from one end of the diameter to that point and the other end of the diameter to that point. Here is a right angle, okay? As expected, because we're going from one end of the diameter to the other, connecting those together to kind of make two chords, they will meet at a right angle, okay? And then again, we can look at somewhere else on the circle. We've called it R. Let's look at it at the point R. Connecting those together, we get another right angle, okay? And the right angle is there. Now at GCSE, you might have seen this in circle theorems. You might have seen that an angle in a semicircle is 90 degrees. In other words, if we draw ourselves a semicircle here, it's not going to be perfect. Let's say that was a perfect semicircle, okay? This is my diameter. We'll highlight it in yellow. That's the diameter. If I take from one end of the diameter to the other, if I take from this end to there, that point in orange, okay, and I do the same thing from the other end, that angle is 90 degrees, okay? Angle in a semicircle is 90 degrees. But it works if we've got a full circle as well, just taking from 2 points or the two ends of the diameter, okay? So I'm going to look at this triangle. Let's drag on my shaded region. I'm going to look at that shaded triangle there, and that's the reason we called it point R. I'm going to look at triangle PQR. P or PRQ, doesn't really matter. Let's go alphabetical. Oops, PQR. Okay? So I'm just going to put that into writing what I've said really here. My first point is that this angle here, if that is the angle, PRQ. R's got a little hat on. What we do, if you have not seen that notation before, is PRQ. The point in the middle is the angle we're talking about. So PRQ is this angle here, okay? If that is 90 degrees, then R lies on the circle with diameter PQ, okay? It lies on the circle there, it's on the circumference with the diameter PQ, as I've kind of said as just explaining that. You could also say if this is the diameter, connecting those 2 points together at point R will give a right angle. Or the other way around, if R is 90 degrees, then R lies on the circle with diameter PQ, okay? And again here, like I've already said, the angle in a semicircle is always a right angle, and at GCSE you've probably seen that, like I said, in circle theorems. Okay, now let's just have a look at how we can find the centre of a circle given 3 points on the circumference, okay? So we can see here is 1 point. I will highlight it in green. There's 1 point, there's another, and there's another, okay? I've only connected 2 of the points together, really. I've only done 2 lines, okay? I've connected those 2 points together and those 2 points together. I've not completed the triangle like that because that's not needed for the minute. We only need 2 chords to find the centre of the circle, okay? Here's 1 point, here's another, and then this red line there is 1 chord, there's another chord, okay? We can see, before I did that highlighting actually, those 2 yellow dots are the midpoints of the chords. So that means here, this line is a perpendicular bisector because it passes through the midpoints. And I'll put an arrow, so is that one there, okay? So the two red lines are the chords, and we can see that they are intersecting, and like I said right at the top here, the blue point is the centre of the circle. All the perpendicular bisectors intersect at the centre. So looking here, if we have two chords, we have 3 points on the circumference, two chords, and two perpendicular bisectors, we can work out the centre of the circle, because the centre is where the two perpendicular bisectors intersect. The reason I didn't include this one here is because it's not going to be very helpful, because we're just going to get another intersection point about there, where this is the midpoint of the line, okay? I don't really need that. That's extra working I don't need. I just need two of them to work out the intersection point. I can work out maybe the equation of this line, or this perpendicular bisector, the equation of this perpendicular bisector, and just set them equal to work out the centre of the circle. Okay? So let's have a look at two examples. Let's have a look first of all what I'm doing here. So that's basically what I've just said, okay? One, connect the points together. So connect those points like that. Find the equation of the perpendicular bisectors, and then find the coordinates of the point of intersection of the perpendicular bisectors. That's what I've just said. Okay. Okay, let's have a look at the first example. So it says the points A 2, 6, B 5, 7, and C 8, -2 lie on a circle. Part A says show that AC is a diameter of the circle. Now it just says a diameter, okay? It does not say the diameter, because there's more than one diameter to a circle. They all have the same length because this is the same circle, but we could have a diameter connecting these 2 points together, okay? Or another 2 points on the circumference, we could have these 2 points connecting those 2 points together, crossing through the centre would be a diameter. Same with these two, same with these two. You know, you can kind of keep moving your diameter as long as it passes through the centre. Okay, so that's why it says a diameter. And then part B says write down an equation for the circle. So write down, do you have to do much maths? Maybe you do. You'll need to know the centre, you'll need to know the radius. So see what you can do with that. Pause and have a go. For part A, think about a right angle in a circle and what does that tell us, okay? Pause and have a go, and then we'll work through the answer. Okay, part A, I'm going to think about right angles. So, it's saying show that AC is a diameter of the circle. So we're being asked to show that. So because we're being asked to show that AC is a diameter, AC must be a diameter. I'll take that as true, okay? But we need to show that somehow. Now to show that, I'm going to go back to right angle triangles in a circle. If AC is a diameter, then connecting the third point to A and C means that this here must be a right angle. So I'm going to use Pythagoras. Okay, I'm going to use Pythagoras to help me here, and I'm just going to find the solution, okay? So I might do a little sketch. We don't really have to. It might be quite useful for us to do it, and I don't think, no, in the book there is no sketch, but we can do a little sketch to help us, okay? Here is AC. Okay, A is at 2, 6, so you might have to tilt this actually, and C is at 8 -2, so yeah, it's going to be something like that. Not perfect, but something like that, I think. Okay, 8 -2. And then we can see B is going to be at 5, 7. So let's just move this over a little bit. B is going to be at 5, 7. So 5 and then 7, it's going to be something like that. Might not be perfect, but there's my quick sketch, okay? And then we have the circle that kind of passes through like that. Again, not a perfect circle, just gives us an idea, okay? Maybe we do put a perfect circle on actually. Let's take away the fill and let's put on a perfect circle. Okay, something like that, okay, where this, just move that down a little bit, passes through the centre of the circle, not perfect, but about there, okay? So show that AC is a diameter. If it is a diameter, this connecting like that and that connecting there means this is a right angle. So let's work out the length of AB, let's work out the length of BC, and let's work out the length of AC. And because it's right angle, let's test whether Pythagoras works. That's what we'll always do in these questions, because Pythagoras only works for right angle triangles. If it does work, the triangle is right angle, so that means AC is a diameter. So let's do that. Let's work out the length of BC, and we'll do that here. It's going to be the square root of the change in x, which is 2 minus 5 squared, plus the change in y, which is 6 minus 7 squared. And let's work out what that is. So 2 minus 5 is minus 3 squared, plus 6 minus 7 is minus 1 squared. That's going to be the square root of 10, I believe. Okay, the length of, oh, not BC. Why did I write BC? That should be AB. AB. Okay, let's work out the length now of BC. Okay, the length of BC will be the square root of change in x, 5 minus 8 squared, plus 7 minus 2, that's a plus 2. That's going to give me the square root of 5 minus 8 is minus 3. Square that, plus 9 squared. That's going to be 9 plus 81 is the square root of 90. Okay, 9 plus 81, that's correct. Then let's work out the length of AC. And the length of AC should look something like this. We'll take the square root, we'll do the change in x, 2 minus 8 squared, plus 6 minus 2, will give me a plus 2. Square that, square roots of then 2 minus 8 is minus 6 squared, plus 8 squared. That is then the square root of 36 plus 64, which is the square root of 100, which of course is 10, okay? So that's what we've got there. This, I write them on in orange, is a length of 10. This is a length of root 10, and this is a length of root 90, okay? So maybe you didn't have to sit and watch me do all of that calculation, but there we go. So, if this is a right angle, Pythagoras will now work. Pythagoras says if I take the square of this shorter side and the square of this shorter side, I add them together and square root, that should give me the length of this longer side, or the length of the hypotenuse. Okay, so let's do that. Pythagoras says this. AC squared will be equal to AB squared plus AC squared. In other words, AC is the square root of AB squared plus, not AC squared, sorry, BC squared. BC squared. Okay, so let's substitute that and find out what AC is. AB, we know, is root 10, so square it will give me 10, okay? BC is root 90, so square it will give me 90. That's then going to be the square root of 100, which we then know is 10. And we can clearly see AC is 10 here, and AC is 10 by just using the points on the circle. So Pythagoras works, therefore AC is, and I should put A, diameter of the circle. Okay, now I have actually ran out of room here, so what I will do is I will just make all of this a little bit smaller. Okay, so hopefully that does make some sense. Now, part B says write down an equation for the circle. Write down is, you know, just quite simple. Can we write it down? We need the centre and we also need the radius, okay? I can work out the radius because we know that the diameter is a length of 10. So to work out the radius, I'll just divide it by 2. So this part must be 5 and that part must be 5. So we have a radius of 5. The centre is going to be the midpoint of the diameter. Okay, so we can work out the midpoint here by working out the midpoint will give me the centre. So the midpoint will be adding the x coordinates together divided by 2 and adding the y coordinates together divided by 2 will give me 5 and 2. I think that will be 10 over 2, which is 5. That will be 4 over 2, which is 2. So that's the centre of the circle. So we have the radius and we have the centre. So we can definitely work out the equation. The equation, and I'll just write it shorthand like that, is going to be x minus 5 squared plus y minus 2 squared is going to be equal to the radius squared of 25. That is your equation of the circle. Okay, let's have a look at the final example for this video. We've got 3 parts here. It says the points P, 3, 16, Q, 11, 12, and R, minus 7, 6 lie on the circumference of a circle. The equation of the perpendicular bisector of PQ is y is equal to 2x. Okay, so what we're doing is we're connecting these points together to form a triangle. Those points are on the centre, on the circumference, sorry, of the circle. And the perpendicular bisector, the line that runs through the centre and the midpoint of the PQ, or the line PQ, the chord PQ, if you want, is y is equal to 2x. Part A, find the equation of the perpendicular bisector of PR. Part B, find the centre of the circle. And C, work out the equation of the circle. So pause and have a go and then press play when you're ready. Okay, so to start part A, what I'm going to do is I'm going to work out the midpoint of PR, okay? Because I need the equation of the perpendicular bisector, so I need the gradient of the bisector, and I need a point that it passes through. And we know that the bisector of a chord, the perpendicular bisector of a chord, passes through the midpoint. So let's work out the midpoint of PR. The midpoint of PR, I will just add the x coordinates together. So from P, that gives me 3, and from R, that gives me minus 7. Divide that by 2, and then we'll have 16 plus 6 divided by 2. This came from the 3 and the minus 7, and then this came from the 16 and the 6, okay? And when I do that, I'm going to get minus 2, and I'm going to get, that's going to give me 22, minus 2, 11. Is that right? Yes, it is. Okay, so that's the midpoint of R. We're going to need that in a minute. Right, I then need to work out the gradient of the bisector. Now to do that, we'll work out the gradient of PR. Okay, then we'll take the negative reciprocal to give me the gradient of the bisector. So let's work out gradients of PR. I will do the change in y, and I will take P away from R. So the change in y is going to be 6 minus 16, and then the change in x is going to be minus 7 minus 3. Okay? 6 minus 16 is minus 10, and minus 7 minus 3 is minus 10, so that is minus 1, okay? Is 1. The negatives cancel out. So, then we will take the negative reciprocal to work out the equation of the bisector. The negative reciprocal, that tells me M, we'll call, is the gradient of the bisector, is the negative reciprocal, which is just minus 1. Flip the fraction, it's just 1, so it'll stay as 1, and then do the opposite sign. So we're going to do negative here. So we're also going to need that for the equation of the bisector. We will then substitute into y minus y1 is equal to m times x minus x1, where, and I'll do it in green, where y1 is this and x1 is that, because that is the point that we know the bisector passes through. So let's do some substitution. We will have y minus 11 is equal to m, which is the gradient of the bisector, which is minus 1, times x minus x1, that's going to be a positive 2. And I'm going to leave my answer like that because it does not specify a form of the straight line. So that is your final answer. Y minus 11 is equal to minus 1 times x plus 2. You could rearrange if you want to into mx plus c, but you don't have to. Okay, we then want to find the centre of the circle. So I'm going to go back to this explanation here, okay? If we know two perpendicular bisectors, or if we have two chords, and we then have the equation of two perpendicular bisectors, the intersection is the centre of the circle. Right, well, what do we have for this question? For this question, we have a perpendicular bisector of PQ that has equation y equals 2x. And we've just worked out the perpendicular bisector of PR. We know it has this equation. So the centre of the circle is going to be the intersection of those two bisectors. Let's work out the intersection. So B, the intersection of y is equal to 2x, the equation of the bisector of PQ, I think, yes, and y is equal to, and let's write it in mx plus c form. It's going to be minus x plus 9, that's just come from there, is the centre. Okay, so let's substitute, if you like, or just set them equal to each other actually, because they're both equal to y. Let's do that to find the intersection. So 2x is equal to minus x plus 9. We will add x to both sides to give me 3x is equal to 9. Divide by 3 gives me the x value at the centre. X is equal to 3. I will then substitute into y is equal to 2x to work out the y coordinate of the centre. So that tells me then that y is 2 times 3, which is 6. Therefore, the centre of the circle is at 3, 6. Okay? And that is correct. So that makes sense. We've got one equation given to us, we've just worked out another. They're both perpendicular bisectors. Find the intersection will give me the centre of the circle at 3, 6. So part C then says work out the equation of the circle. Well, the equation, we need the radius and we also need the centre. We've just worked out the centre, so now let's work out the radius. I'm going to find the radius by working out the distance between the centre, which is 3, 6, and I'm going to take point Q, which is, and what's point Q? It is 11, 12. Okay, you could have actually taken any points, but I'll just take Q because that's what the book does and it's quite simple to do. Okay, so the distance is going to be the square root of the change in x, which is 3 minus 11 squared, plus the change in y, which is 6 minus 12 squared. Okay, and when you do the maths on that, you can just put it into a calculator. You do get 10. Okay, the square root of 100, so we get 10. Okay, so that is the distance between the centre and a point on the circumference, so that is the radius of the circle. Okay, so all we now need to do is substitute into x minus a squared plus y minus b squared is equal to r squared, and hopefully getting used to that being the centre and the radius, so C being the centre AB and r being the radius. So substitute in, we get this. We get x minus 3 squared plus y minus 6 squared. R is 10, so r squared must be 100, okay? And that is the equation of the circle.